Good morning, everyone. Today we are going to talk about trigonometric functions and acute angles. And trigonometric functions applicable when I have or whenever we have a right triangle. Even if we don't have it, we are going to try our best to create it. Then we will be able to apply trigonometric ratios. What are those trigonometric ratios and how can we apply them and when can we apply them? All of those questions we are going to answer them in our lesson. Okay, let's see here. So here we are going to write here that this one is applicable whenever we have a right triangle. Okay, whenever we have a right triangle. Let's talk a little bit about the right triangle before we start. I want to tell you that this is my right angle, and now this is my hypotenuse. Okay, always it's the longest side or the side that faces 90 degrees triangle. 90 degrees, sorry. Okay, and again, the same thing here. This is my right angle, and this one faces the hypotenuse, which is the longest side that in our triangle or that faces 90 degrees angle. Okay, let's say that this is my theta. So always you have to stand there. See, I'm gonna just draw a man or a boy, okay, which here he stand here, and this is our opposite, okay. This is our opposite, and based on this is our adjacent. Okay, like let's see here that I have this is my theta. My theta here, this is my opposite. Okay, my theta, this is my opposite. And now this is my adjacent. Okay, this is my adjacent. What are those trigonometric issues? Now, I have three basic ones, sorry, and we have reciprocal formulas. So the three trigonometric ratios here, or I mean the basic ones, ratios are what? Sine theta, pay attention that sine alone without an angle useless. So I have to have an angle to find it. So it's kind of operator. So sine theta equals opposite over hypotenuse. Opposite over hypotenuse. And cosine theta equals adjacent over hypotenuse. Adjacent over hypotenuse. And tan theta equals sine over cosine, okay, or cosine theta, or opposite over adjacent, okay? Okay. Then after this, we will have the reciprocal functions. What are the reciprocal functions? Reciprocal functions. The reciprocal function says what? For sine, I have cosecant. What do we have? Cosecant. So pay attention here. SC cosecant equals 1 over sine theta or hypotenuse over opposite. Okay? Hypotenuse over opposite. And cosine theta, the reciprocal for it is what? Secant theta equals 1 over cosine theta. And see here, this is SC. Okay, so this one is hypotenuse over adjacent. And tan, the reciprocal for tan is what? Cotangent. Cotangent theta equals 1 over tan or cosine theta over sine theta or even adjacent over opposite. How can we apply them? Simply, we are going to take a so simple example right now. Then after this, we will move on or we will get something hard. Okay. How can we apply this? For example, let's say I have this example. Let's say that I have this triangle, as you can see. Let's draw this one. This is my triangle. And again, here I have this one. And this one also is given. So he told me that this is our theta. So the triangle, sure, it's going to be given. And here I have, this is 35. Let's say that this is 37. And here this is 12. Again, where is my right angle? Excellent. This is my right angle. And where is my hypotenuse? This is your hypotenuse. Excellent. And regarding to the theta that he picked, this is my opposite. Excellent. This is my opposite. And where is my adjacent now? This is my adjacent. What are 6 trigonometric functions? If the question asks you to find what are the 6 trigonometric ratios, 6 trigonometric ratios for angle theta. So how can I solve it? For theta. So how can I solve it here? Let's see. So already we memorized the formulas. So this is the first step here to master this ability. Then after this, you are going to apply them. Sine theta. Sine theta, it's opposite. So what is your opposite? Excellent. 12 over adjacent, which is 37. And what is the reciprocal? Cosecant theta equals 37 over 12. CSC, okay? Then after this, I have cosine theta equals, excellent, adjacent, which is 35, over hypotenuse, which is 37. What is the reciprocal for cosine? It's secant theta equals 37 over 35. Excellent. Tan theta, opposite, which is 12, over adjacent, which is 35. And the reciprocal for tan is what? Cotangent, which is here 35 over x. So this is one of the questions. Maybe I'm going to ask you to find a specific value. I mean, sine or cosine. So it depends. But generally, you are going to memorize the formula, then apply. Okay, let's say that I have this example. He told you what are trigonometric ratios of an angle. So this is another way to ask you the same question. So what are trigonometric ratios of an angle, and this angle here is theta, of an angle theta with, in a right triangle. So I have to mention this, or he has to mention this, in a right triangle, in which sine theta equals 24 over 25. So here he give you sine. He give you sine, right? So he wants the rest. So he give you sine theta equals 24 over 25, which is here again opposite over hypotenuse. Excellent. And what's the reciprocal of sine? Cosecant. Excellent. Cosecant theta equals, flip it, so it's going to be 25 over 24. Excellent. Let me move on here. What are the rest here? Cosine theta. I need to know what is the adjacent. And based on this, we are going to find secant. Flip it. Okay, the reciprocal of cosine. And tan here, it's opposite over adjacent. And I have here, or after this, we can find simply the cotan theta. Okay, so first step here to solve is to draw what? To draw the triangle that we have now. So how can I draw this triangle? See, we are going to draw this triangle, as you can see. It depends. You can draw it in this way, or even you can draw it in this way. What do you prefer? It's fine. Pay attention, where is only the position of right angle. So this is my right angle based on the only given here, which is sine. The only given sine theta equals 24 over 25. So where do you prefer to choose theta? It's fine, up to you. So I'm going to choose it here. You can choose it there, so it doesn't matter. Okay, so what is your opposite? This is my opposite based on my triangle. And where is my hypotenuse? This is my hypotenuse. Okay, now how can I get this one, the adjacent for this theta, using Pythagorean theorem? How can I use it? So it's going to be what? I want to find the adjacent. So we are going to say here, adjacent square, based on this angle, plus 24 squared equals the hypotenuse square, which is here 25 squared. So how can I get the adjacent square? So it's going to be 25 square minus 24 square. So adjacent square here equals 49. How can I get the adjacent alone? So take square root for both. So this one will be 7. So what is the length of the adjacent? This one here will be 7. After this, what shall I do? We are going simply to find what is cosine and find what is tan. Cosine theta will be 7 over 25. And based on this, the secant will be flipped. So it's going to be 25 over 7. Tan, it's going to be what? Opposite over adjacent. Excellent. So 24 over 7. And cotan based on this will be 7 over 24. I hope it's clear for now. Okay, let's move on. There is something else which we can use it actually in the tricks. We can solve right or any kind of triangle, honestly. Whenever we satisfy the right angle, we can find the length of the side very quickly using something we call it special triangles. Special triangles. So we can use special triangles, honestly, to solve a lot of questions, even in SAT or EST or GAT. We can solve it very quickly and using this property, honestly. Special triangles. Let's see. The first one here says what? If I have an isosceles right triangle, so what's the meaning of isosceles? Isosceles, sorry, that means we have two sides are congruent. So see here I have this is 45 degrees and this is also 45 degrees, right? And this is my right angle. What is the opposite side here? This is hypotenuse, excellent. And those are congruent. Why congruent? Because they have the same length of, sorry, the same size of the, or measurement of the angle. So this is 45 and 45. So that means those sides are congruent, right? So let's say this one is x and that one is x. So how can I get the hypotenuse using Pythagorean theorem? Pay attention that we will not use Pythagorean theorem anymore later on. But for now, it's going to be x squared plus x squared equals a hypotenuse squared, right? So take it here, it's going to be 2x squared equals hypotenuse squared. So take square root for both. So it's going to be here x radical 2. This is my hypotenuse now. So we will take it as a rule. Actually, I use this one only to prove that this triangle applicable for any isosceles right triangle. Okay, so this one is going to be your rule. So if those two sides are x's, so that means the hypotenuse will be x radical 2. Let's say here that I have this one. So this is 45, 45, 90 degrees triangle. Okay, let's say that I have this one, 30, 60, 90 degrees. So let's say here I have this one. Okay, what do you think? Where should I put 30? 30, it's supposed to be up. Excellent. It's supposed to be up. Why? Because this is the smallest angle which is supposed to face what? The shortest side. And here, this is 90. This is my hypotenuse. And this one is going to be for sure 60. Because the sum of the angles in any triangle is what? 180. Excellent. So if this one is x, and the hypotenuse, which is the longest side, it's 2x. So that means the one that faces 60 is what? X radical 3. And actually, it's applicable for any 30, 60, 90 degrees. And here also, you can prove it using Pythagorean theorem. So see here, the angle that faces 30 is x, the angle that faces 60 is x radical 3, and the hypotenuse will be 2x general. How can I apply those things here or those two special triangles to find unknown measurements or to solve any triangle? Let's see how. Let's have here some examples. Okay. Let's say that I have this example. Just a second here, I'm going to show you here another one. Yes. Yes. Let's imagine that I have this triangle. Okay, I have here this kind of triangle. All those are my questions he wants from you to find what is x and what is y. So how can I solve it? Yes, let's see here how we are going to solve it. Yes. I'm going to just fix it here to be here. Yes, excellent. Okay, so see here, what do I have? How can I solve this one? This is 45 and this is 90. Based on this, for sure, this one will be 45. Because the sum of the angles in any triangle, for sure, is going to be 180. 180 minus 90 plus 45 equals 45. If this one is x, this one also is x, right? This one also is x, right? So let me just draw it here out. Yes. So if the hypotenuse here is given as 6. So I'm going to just remind myself with the basic triangle that we memorized. We said if this is x and that one is x, that means this one is x radical 2. This is here 45, and now this one also is 45 degrees, right? Let's solve it together. How can I get x and y? So how can I solve it? See, he told you that the hypotenuse exactly equals 6. So hypotenuse equals here x radical 2 in the formula, right? And the given hypotenuse equals 6. So I'm going to just take x radical 2 equals 6. I want x alone, so divided by radical 2, divided by radical 2. So x itself equals what? 6 divided by radical 2. So can I keep here radical 2 in the denominator? No, we will not. So we will rationalize the value. So radical 2 is going to be 6 radical 2 over here 2. This 2 will go with this 6. So it's going to be what? 3 radical 2. So what is x now? It's 3 radical 2. And what is y? 3 radical 2. Okay. How did we know it's 45? Because this is given x. Okay, let's solve another question. He said this is a 45 right triangle, as you can see. Based on this, you are going to know directly that this one also is what? 45 degrees, right? The hypotenuse here is given as what? The hypotenuse here is given as 2 radical 6. 2 radical 6. So what's the hypotenuse? We've memorized already. So this one is x radical 2, right? So x radical 2 equals 2 radical x. Sorry, radical 6. So I'm going to just take it down. X radical 2 equals 2 radical 6. I'm going to just solve the equation. So I want x alone, so I will divide here by radical 2. I will divide here by radical 2. So x itself equals 2 radical 6 over radical 2, right? Can I leave it like this? No, we can't. So we are going to rationalize the fraction. So we will multiply here by radical 2, multiply here by radical 2. So it's going to be what? X equals 2 radical 6 times radical 2 over 2. This 2 will go with this 2. Under the fraction here, what do I have? I have, this is 6. 6 here is 2 times 3, and I have 2. So we can take 2 out of the radical. So 2 here, radical 3. So this is now x. How can I write it? I will come back. X here equals what? 2 radical 3. So x here equals 2 radical 3. And y also 2 radical 3. I hope it's clear for now. Let's take something which is easier, just to generalize here. If I give you this one like this, if I give you this one 4 and this one 4, and I told you this is right and this is 45. So directly you are going to say that the opposite here will be x and 4 radical 2 without using or spend a lot of time to calculate and use Pythagorean theorem. So directly you will know that this one is 4 radical 2. Okay, let's take one more question or one more example. I know some students, they hate this part, but actually it's nice when you just understand it. You will find it useful. Okay, let's take one related to 360 degrees. Okay, as you can see, this is our question. Yes, this is our question here. Yes. I hope it's clear for you now. Yes. Okay, let's see. Have a look. Try to understand how can we solve it. He wants from you to find what is x and y. Okay, this is all right. This is 60. Directly, this one will be 30, right? We said here, this one is the hypotenuse, which faces the longest side. And if you still remember, what was our triangle? What was 30, 60, 90 degrees ratios we said here. For 30, it's x. The one that faces 30 is x. The one that faces 90 is what? The one that faces 90 is 2x. Excellent. The one that faces 60 is what? X radical 3. Okay? So what is the hypotenuse here? Excellent. Hypotenuse here equals 16, which is exactly equals to x based on our triangle here, based on our triangle. So 16 equals to x divided by 2 divided by 2, x equals 8. Where shall I write here this 8? The one that faces angle 30. So here y equals 8. Excellent. Y equals 8. So I'm going to write here y equals 8. Okay. Now only here we are just solving, so please just pay attention with the position of the angle, but randomly, I mean just to call it x generally, okay? And the one that faces 60, angle here that faces 60, angle that faces 60, side that faces 60 degrees, side that faces, side that faces here, faces 60 degrees angle equals what? X radical 3. So what is x? It's 8. Radical 3. So it's a rule. So I'm going to write here 8 radical 3. I hope it's clear for now. Okay, let's solve one more here. He told you this is 30, and based on this, and this is 90. Based on this one is what? 60. And the unknown here is what? The hypotenuse plus the angle that faces 60. So what is the hypotenuse here? The angle that faces, sorry, the side that faces 30, side that faces 30 is x, right? Is x, right? So x here equals 2. Okay, x equals 2. Based on this, the hypotenuse will be 2x. So u equals 2 times 2 equals 4. The side that faces 60 degrees, 60 degrees. So it's going to be what? 2 radical 3. Excellent.